the last set of examples here asks us to rewrite those expressions with positive exponents. So if I take a look at number 1, m to the negative third times n to the fifth. Well, n to the fifth is good. It has a positive exponent. However, this negative 3 on m is not good. This whole fraction is really over 1. So I only need to move the term that has the negative exponent. So n to the fifth is staying up top. M needs to drop to the bottom, so then its exponent can become positive. Technically, it is multiplying the 1 that is already down there. However, 1 times anything is that term back. So 1 times m to the third is really just m to the third. For number 2, pay attention to what exponents each term has on it. So the 1 in the top, technically that 1 in the numerator is raised to the first power. It's good. In the denominator, here's the trick. Is this negative 3 an exponent on 7? No, the 7 really has a 1 as its exponent. So the 7 is going to stay in that denominator. It is not moving. It has a positive exponent. However, the k needs to move so it can get a positive exponent. So to get that exponent on k to be positive, we do need to move it to the top of the fraction. So remember, if it's in the top of a fraction, move it to the bottom. If it's in the bottom, move it to the top. For number 3, 15r, that quantity is raised to the 0 power. Anything to the 0 power is 1. Some students might say, well, wait a second, don't you have to distribute this exponent to both? You can. Make it 15 to the 0 times r to the 0. But 15 to the 0 is 1, r to the 0 is 1. And 1 times 1 equals that 1. Heck of a lot less work just to say that anything, that whole thing would be 1. Whole thing is to the 0 power, so that whole thing does equal 1. For number 4, 2 on top. That 2 on top is to the first power. It's good where it is. One of 2 ways we can go from here for number 4. One way is to say 8x, that whole thing is being raised to the negative third. It needs to come to the top to become positive. Multiplying when it comes up there, that's now to the positive third. Well, we don't leave sets of parentheses being raised to an exponent. That is multiplication, so we are able to distribute that exponent through. So we do have 2 times 8 to the third times x to the third. You could evaluate that further if you wanted to. Take what 8 to the third is and get that numerical value and then multiply that by 2. 8 to the third is 512. So I would do 2 times 512. Exponents come before multiplication. And then I could multiply that 512 by 2 and get 1024 x to the third. I'm more worried about you using those properties of exponents than actually evaluating. Evaluating's pressing buttons on a calculator. The other way you could do this is to distribute first. So I could have done 2 over 8 to the negative third times x to the negative third, and then brought both the 8 and the x to the top. That would get me to this step here. Either way is perfectly fine. Make sure that 2 stays in the numerator of the fraction. It has a positive exponent. Number 5. First thing I'm going to look at is that I have this negative on the outside. I'm going to decide to distribute. So this negative 3 needs to go on the 4 and on that n to the negative 2. So I would have 4 to the negative third, n, power of a power, multiply those. Negative 2 times negative 3 is 6. Can't leave this negative exponent. This whole thing is really over 1, so that 4 needs to drop to the denominator. The n to the 6th can stay up top. It has a positive exponent. So when the 4 drops to the denominator, its exponent then becomes positive. You can actually evaluate there. N to the 6th over 4 to the 3rd. 4 times 4 is 16. 16 times 4 is 64. So again, the evaluation part, not such a big deal there. You could, if you wanted to, do what we did here first and flip first. So I could have taken all of that to the denominator and said that that's 4n to the negative second, now to the positive third. Notice that negative 2 doesn't change. All I can do is one thing at a time, which is to change that negative 3 to positive. Now I can distribute. Power of a power, multiply, and now the n to the 6th would need to come to the top. So n to the 6th over that 4 to the 3rd, and you can evaluate that for your final answer. So the reason I'm showing you these different ways is to show you that there are different ways. You end up doing the same properties, it's just a matter of what order those properties are done in, and it makes no difference as long as you use those properties correctly. For number 6. That 4 is really raised to the first power. It is multiplying. The only reason those sets of parentheses are there is to show that that 4 is multiplying 3 to the negative k. 4 is to the first. It doesn't need to move. It stays in the top of the fraction. However, that 3 needs to drop to the denominator so its exponent can be positive. So it's now to the positive k. That's all there is to do there. For number 7, 5 is really being raised to the first power, so it's good as it is. However, G and H both need to move because they both have negative exponents. So 5 stays in the numerator. G drops to the denominator, so its exponent can become positive. Exact same thing happens with H. So again, only the terms that have negative exponents get moved. If it doesn't have a negative exponent, keep it where it is, either in the numerator or the denominator. One of two ways we can go with number 8. You can distribute, then flip, or flip, then distribute. It's the exact same problem as number 5, just some different numbers in there. So I can distribute and say that that's 4 to the negative third times y to the negative third. We can't have that. Both of these need to move, so it would be 1 over 4 to the third times y to the third. 4 to the third, again, is 64, so I could make that 1 over 64y to the third. If you wanted to flip first, that's absolutely fine. It's over 1. I would make it 1 over 4y to now the positive third, distribute that exponent, and you still get to that same final answer. So one way or the other there, again, order does not matter. In number 9, the only thing I can do with number 9 is to make that negative exponent positive. Right now, that base is in the denominator, so I move the base to the numerator and make its exponent positive. That's it. Nothing else to do with that. Number 10 takes us back to a property that we had before. Multiplying same bases, the product of powers, keep that base the same, and add exponents. So that's really 9 plus negative 9. But 9 plus negative 9, really 9 minus 9, is 0. Anything to the 0 power is 1. I will mention not to get, as I refer to it as, flip happy. Don't worry about negative exponents right from the beginning. Negative exponents are the absolute last thing I worry about. I'm not worried about the negative exponents until the end. Do any other simplifying that you can do. There's a reason that we did the other properties first. Use those first. Exhaust those before you worry about there being negative exponents. Is there a power of a power? Do that first. Is there the power of a product? Do that first. So worry about those properties first. Then the last thing we have to make sure is that there are no negative exponents. If there are, then we need to move them. Again, only the ones that have the negative exponents move. If they're in the numerator of a fraction, drop them to the denominator. If they start in the denominator, move them up top to that numerator. So again, still using those same properties. Don't forget about the product properties that we talked about. Now we're adding in these negative and zero properties as well.